Hey everyone, my name is Kirill. I'm the head of research at Blockscout. So let's jump into the Blockscout Workshop. So if you haven't heard about Blockscout before, Blockscout is the most widely used open source blockchain explorer for EVM networks, rollups, mainnets, devnets, anything EVM related. So in this workshop, we'll talk what is Blockscout and why you should care about it, why you should use it, why chains should use it. We'll talk about the APIs that are available to the hackers throughout this hackathon to be eligible for a Blockscout bounty of 20K. We'll talk about the contract verification, which is also one of the requirements to be eligible for the hackathon bounty. And then we'll talk about the bounty in a bit more details. So why should you care about Blockscout? Basically, in the past couple of years, we have seen this exploding growth in the number of networks launched. Basically, everyone is now launching their own rollup based on OP Stack, Arbitrum, and so much more. Everyone is having testnets, devnets are being spun out and shutting down. Basically, only throughout this week, we have seen a couple of, I think, 5 network launches or something. And so for all of these networks, any network which is EVM compatible and even not EVM compatible, it needs some sort of block explorer. And so there exist a couple of proprietary solutions, but it's obvious that they are too expensive for everyone to use. They are too rigid, too hard to launch. They cannot be launched quickly in a matter of few hours. So the only feasible option we see here is that there should exist an open source blockchain explorer that anyone can use for free, that someone may host for a small fee, but open source explorers are just something that any blockchain page should absolutely have. So Blockscout has been very successful in its journey and is now being used by more than 1,000 different networks. This includes all the different mainnets, devnets, testnets. Some of these networks are hosted by us, some of them are hosted by different other providers, rollup as a server providers and something like that. And then the most majority of these Blockscout instances are self-hosted by the teams running the chains, by the teams operating their rollup sequencers, and they run it absolutely for free on their own infrastructure, in the public cloud, in a private cloud, and there is no limits where you can use Blockscout. So Blockscout is fully open source. It has a bunch of different components that are all open source that can be configured and optimized and customized for the specific needs your chain have. It has a bunch of different models that can be turned on and turned off for the specific chains, for supporting user operations, data availability indexing, and so much more. It's user-friendly, it's dev-friendly, it has a lot of contributors from the open source space, so Blockscout is fun. So now let's get back to the to the hackathon, to the bounty, and what you should use throughout this hackathon to be eligible for the Blockscout bounty. So we'll start with the APIs. What Blockscout APIs we have that are available to the hackers, what can you use, some different use cases for them. So we have a bunch of different types. So let's start from the first one, which is the REST API. So basically we have this public Swagger on every of the Blockscout instance. You can go and see through a bunch of different REST API endpoints. Basically all these endpoints are the ones that power the Blockscout UI itself. So all the information that you see in the Blockscout UI, such as the address info, the number of transactions, the transaction list itself, the source code of a particular contract, the different token transfers, NFT transfers, and basically anything you can find throughout the UI. This is all fetched through the Blockscout REST API, and you can use the same info you see in the UI by looking and finding the respective API from this list. And then if you like a little bit different format, you don't like REST APIs, you can pretty much use the same data and query it through the GraphQL interface. So among those REST API endpoints I mentioned on the previous slide, one of the most recent additions to that list was the transaction interpretation endpoint. So basically this is a simple endpoint that is available on most of the Blockscout instances that allows you to pass a random transaction hash of an existing transaction on this network, and then the Blockscout will collect a bunch of different data about these transactions, what happened in it. This data will include some low-level information, raw information, as well as decoded info about logs, token transfers, the called smart contract method, and it will use then LLM model to aggregate all of this data and to categorize and trying to interpret this transaction in an easy to grasp and easy to understand format that can be displayed within a couple of lines to the user, just to give them the idea what actually happened inside these transactions. So whether some token or NFT was minted, transferred, maybe something got burned, maybe some tokens were swapped, or just a random unspecified method was called on a specific contract. So what this API does in the end is you give it transaction hash and it outputs you one of the templates from the fixed set of templates we support and have. And then, so it outputs you the template string you can see on the slide, and then the variables you should fill this template with, such as what's the token name, the token amount, the NFT ID, and stuff like that. So if you want to display some summaries of transactions within the UI or something like that, you can use the Blockscout REST transaction interpretation API and microservice for that. So then the second API model we have at Blockscout is an RPC-compatible API. Basically, this is the API that you may be familiar with from other explorers. So a bunch of different explorers support this API format. So if you have some library that operates and uses this particular API format and you don't want to rewrite it, to fork it, you just want to use it as is, or you just very confident, you feeling very confident about using this particular API type, basically we support it too. You can use it to query pretty much the same information that is available through the REST API, but in a slightly different format through the different API query parameters. But again, that's just a different interface. You can query all the tokens, token transfers, logs, information about accounts, blocks, contracts, transactions, anything. And then the last API we have available at Blockscout is JSON RPC compatible API. Basically, it's the same API you use when connecting to the raw JSON RPC endpoint. But here, so we support almost all of the ETH namespace JSON RPC methods. And basically, the best usage for this API in your front ends, in your dApps, as a fallback option to the existing JSON RPC provider. So if you're using Infura or something like that, you can add at the end of the list as a second fallback JSON RPC provider, the Blockscout, JSON RPC endpoint, and your app will just more redundant, it will be more available, and will use an additional source of information for querying its data if the first one goes down, doesn't respond, timeouts, or something happens. So that's pretty much it about the APIs available. Now let's talk about the contract verification for a bit. So the idea behind contract verification is that we are trying to verify the contracts that are available on the network in the format of bytecode. We are trying to match them with the specific source code that you have used to compile, to deploy this bytecode. So the way it works is that once you have an unverified bytecode on some of the networks, we support, you can go through the UI or through different CLIs. We support that I'm going to talk about a little bit further down the line. And you just send your source code files. You specify the settings you use for the compilation, such as the Solidity version, the number of optimizer runs, and so on. And then the Blockscout backend will compare it will recompile your provided source code and compare if the bytecodes match to what we have seen on chain. And if it does, then you will see this beautiful green tick in the Blockscout UI, and the UI will tell you that the contract is now verified. You will be able to browse through its source code. You'll be able to interact it with the read and write contract tabs, and yeah. So actually, in many cases, Blockscout can automatically verify and import some contracts that it has seen already in the past on either the same Blockscout instance under the different address. So for example, if you deploy same contract multiple times to just test it multiple times again and again, high chances that these contracts will be automatically verified because the bytecodes are identical, and if you verify the first one, then the second and subsequent ones will be verified automatically. Then we're able to import identical contracts also from other Blockscout instance connected through the Blockscout bytecode DB database. Then we're able to automatically import smart contracts from other source code verification providers, such as Sourcify. And then in the future, this source code import will be also available to you will be able to directly import any verified contract through that was ever verified on some other different networks through some other different block explorer. And this will all work with the help of the Verifier Alliance initiative, which is basically the idea that we want to create this shared database of all verified contracts. And we are working on it with a couple of different partners, RouteScan, Tenderly, Sourcify, and Blockscout. So this is coming very soon. And if your contract is deployed for the very first time, then you'll have to do some manual actions to be able to verify it. So basically, there are a few ways you can do it. So the simplest way that works best for small and single file smart contracts is you can just go to the Blockscout UI, click some buttons, fill in a couple of settings, submit, copy paste your source code, and verify the contract through the UI. So this works best for the most simple contracts and for Viper contracts. Then you can build your custom verification pipelines by using the raw Blockscout API for the verification. You can verify via any verification plugin, for example, in Sourcify, and then import the contracts into Blockscout. This works well too. You can use some automation tools or dev frameworks to verify and automate your verification too. So if you're confident in using Foundry, there is a flag for that, for verifying your contracts automatically using Foundry CLI. There is the same for Hardhat. Or you can use some automation tools like Catapulta to verify your contracts automatically on multi-chain deployments. And if you want to learn more about the Verifier Alliance initiative, please scan the QR code and follow the news, join the community, and see what's going on there. And the last point I want to talk about in contract verification is that we also support a bunch of different proxy patterns. So proxy patterns is a very common way of deploying contracts nowadays. So whenever you want to do some upgradability stuff or you want to reduce the on-chain footprint of your smart contracts to reduce the gas cost and so on, that's the typical use case for proxies. So, and there are different proxy types that we support. There are immutable minimal proxy standards. There are some storage slot-based proxy standards that put the implementation address under the specific slot. And there are a few others, and we support all of them. The Blockscout UI will automatically detect, so you don't have to click any buttons to detect this proxy. It will be automatically detected once someone opens this contract in the Blockscout UI. And we'll conveniently show the detected proxy type. The UI will also allow you to interact with the underlying implementation directly through the UI when you are going to the proxy address. So now a few quick words about the bounty we have. So we have a very simple bounty throughout this hackathon. So basically it's a 20K of the pool price and that's it. And we're going to split that evenly across all qualifying projects and teams that qualify the following requirements. Basically, depending on the specific you're building or specific projects, we understand that everyone has their own requirements, their own needs. Some teams have smart contracts, some don't. Some need APIs, some don't. So just try to use Blockscout as much as you can throughout your project. If you have some smart contracts, go ahead and verify them. Check that they're verified in Blockscout. Try to interact them with Blockscout. If you need some data, such as token transfers for a specific address, use the Blockscout API to query that. If you have some links linking from your dApp to on-chain transactions that the user submitted through the on-chain wallet, you can put the Blockscout links on that after the transaction submission. If you want to include your dApp in the Blockscout dAppScout marketplace, which is a marketplace of dApps we have for a bunch of different networks, you can also fill out this marketplace submission form. And basically, the most important requirement after that is we just want to see how you use Blockscout in your final presentation. Either it's going to be live in front of our desk, or when you record the video, just mention how you use Blockscout, interact with the Blockscout when you go through and show a bunch of different transactions to the judges. So just show how you use Blockscout in your final presentation, and that's it. You're good, you're qualified. You'll definitely get a share of this 20K prize. So that's it for this workshop. If you have any questions, please ask. Otherwise, happy hacking. Join our communities. And if you have questions after this workshop, please come to our booth, or if nobody is there, please ask them in their ETHGlobal Blockscout partner Discord.